This is section 1.6, a library of parent functions. These notes are going to have a lot more detail than the last two notes did, but it's probably one of the easiest sections that we do. So the first thing that we start out with in this unit is the book introduces you to how to write an equation of a line given the information in a different format. So you're going to be given the information f of 2 equals 5 and f of negative 1 equals 8. Well, you did this in Algebra 1, but you would have just recognized it as the point 2, 5 and negative 1, 8. And we're going to use point slope form and slope intercept form. Point slope form is more useful as you get up in math classes, and slope intercept form was very useful in Algebra 1. I don't use it that often, but you need to be using both forms. So since I have these 2 points, the first thing I want to do is find my slope. And my slope is going to be the change in y over the change in x. I'm using this delta. It's a Greek letter that means change. Instead of saying y2 minus y1, I just shorten it this way. So y2 minus y1 over x2 minus x1. So I get 3 over negative 3, which is equal to negative 1. And you're going to get fractions also. So my equation in point slope form, y minus y1 equals mx minus x1. Well, my y and my x are going to stay my variables. So I have y equals y1, I'm going to use the 5. So I have y minus 5 equals my slope, which is negative 1, and then x minus x1. My x1 is 2. That's point slope form, and I just leave it like that. And it doesn't matter which I call y1 and x1 and y2 and x2. I could have switched these around. This equation would have looked different, but it still would have been correct. Slope intercept form is y equals mx plus b. If I were to rearrange this, I get y minus 5 equals negative x plus 2. If I add 5 to the other side, I get y equals negative x plus 7. And that's slope intercept form. With this section, I said there is a lot of information I'm going to give you, and it's all in the textbook as well, and I will be giving you online access to the textbooks. You have to recognize the names of these functions: constant, identity, absolute value, square root, quadratic, cubic, cube root, reciprocal, and greatest integer. These are the functions that we're going to be talking about in this unit. And you should recognize the equation. So constant function is going to be f of x equals some number. That's what the C represents. And you're going to have to be able to understand what the domain and range are. So if I talk about these, if I look at this constant function, if y is a constant, you just have a horizontal line. So the domain is going to be all real numbers, which I'm going to write negative infinity to infinity. And my range is just whatever this value c is. The identity function, if I were to graph that on a coordinate plane, y equals x has a slope of 1 and it has a y-intercept of 0. That's what the identity function looks like. So my domain is all real numbers. It keeps going forever left and forever right. And then my range is also all real numbers. The lowest it's going to go is negative infinity to infinity. And notice, like I said before, interval notation, the smallest number is always on the left. This absolute value function, if I graph it on a coordinate plane, looks like this. So it's taking this line and keeping all the y values positive. So this part is this part. But this part here, if you reflect it up, it goes in that direction, it becomes absolute value. So my domain is all real numbers, and my range is never going to go below 0. So it's going to go from 0 to infinity, and it includes 0. My square root function, or radical, it's one of my favorite ones to work with. You'll see me use this one a lot. It looks like this. It starts here at 0, 0. So my domain is from 0 to infinity. And then from 0, not only does it just go to the right, it also only just goes up. It's never going to change that. So my range is going to be from 0 to infinity. Quadratic function you've studied frequently in Algebra 1 and Algebra 2. Quadratic function looks like this. So the domain is just the same as absolute value. In fact, the range is the same. The difference between these two is the absolute value has a point right there. The vertex is a sharp point. A quadratic function is a polynomial, so the vertex is smooth and rounded. Another polynomial is this cubic function, f of x equals x cubed. And I did one of these in the last notes. A cubic function looks like this. So we talked about even and odd functions. The quadratic function is even. The cubic function is odd. So my domain, left, negative infinity, to the right, positive infinity. My range, down is negative infinity, up is positive infinity. The cube root function. The cube root is the inverse of the cubic. And we'll talk about other inverse functions later on. So to graph this one, it looks similar, but it's kind of like a horizontal version of it. Oh, it should be symmetrical. It's not drawn perfectly. So my domain left is negative infinity, to the right is infinity, so all real numbers. Furthest it goes down, this is going to keep going, but it keeps going to the left, but it's also going to keep dropping down. So it goes to negative infinity and goes up to infinity. The reciprocal function's a lot more unique than the other functions that we study. We're going to spend a section alone just on reciprocal functions. This particular reciprocal function, 1 over x, is all in the first quadrant and all in the third quadrant. So cube root is odd. Reciprocal function, just this specific one, is odd. My domain, it goes from negative infinity to 0, and then 0 to infinity. Or I could say x cannot equal 0. To me, that's a little bit easier, but you can use the other notation. The range is the same thing. There's a vertical asymptote at x equals 0. There's also a horizontal asymptote. So I'm going to just say y cannot equal 0. And the last function that we study is this greatest integer function. If there's time in Algebra 2, it can be studied. There's not always time. It's also called a step function. And you can see this, it looks like stairs. So the domain on this, where this open circle is, straight above is a closed circle. Where this open circle is, straight above is a closed circle. And this continues in all directions. So my domain is going to be all real numbers. But the range on this function, these are only going to be integers. So this is 0, this is 1, this is 2, this is -1, this is -2, and it keeps going in that way also. So I'm going to say It's just integers. Also in this section, we're talking about parent functions. We look a little bit further at piecewise functions, which I've mentioned before. Piecewise functions, I want you to graph each piece accurately. You're going to use open circles when the point is not included and closed circles when the point is included. And the completed graph must pass the vertical line test. During the live lesson, I will do some examples. Greatest integer functions, the output value is an integer. You use open circles when the point is not included, closed circles when the point is included. Those are the same instructions for graphing piecewise functions. And the completed graph must pass the vertical line test. So there are similarities to these because they are both discontinuous, or they can be discontinuous. They don't have to be discontinuous. And I will spend time talking about those on the live lesson.